This video is a one-page tour of a Wi-Fi 7 frame across three layers of the stack: the MAC, the PHY, and the radio or RF frontend. This layout helps you visualize the vertical story and the horizontal story. Vertical story is about how a frame descends from software down to actual radio waves. The horizontal story is about how the frame marches through different states in each layer. Let's start at the top with the MAC layer, which is the decision maker. On the transmit side, the MAC begins in idle with nothing to send. The moment a frame is queued, it moves to frame pending state, then has to win the medium through channel access, that's CSMA/CA with EDCA contention. Once it secures a transmit opportunity, TX-OP is acquired. The interesting Wi-Fi 7 work happens in schedule and build. This is where multi-link operation picks which link to use and where the resource units, MCS, and spatial streams get assigned along with frame aggregation. Then it hands off to the PHY, waits for an acknowledgement in ACK-wait, and then either lands in success or fail. And notice the fail state isn't terminal. It loops back to retry until the retry limit forces a drop. The receive side mirrors this more simply. Monitor the medium, detect a frame, receive it, validate the FCS, and decrypt, then deliver the MSDU up to the network stack. Drop down to the file layer and notice the label says per link. That's the crucial Wi-Fi 7 detail. With multi-link operation, you have parallel 5-state machines running independently on each link. The PHY's transmit job is signal construction. Take the MAC's configuration, build the EHT preamble with its training fields, encode and modulate the payload with LDPC, run the OFDM generation through the IFFT, and stream digital IQ down to the radio. The receive PHY is where most of the hard DSP lives. Synchronization, PPDU capture, channel estimation of the long training fields, equalization and demodulation, DPC decoding, and finally an FCS check. At the bottom is the radio layer, labeled per chain, and that distinction matters. Wi-Fi 7 supports up to 16 spatial streams, so you have a separate RF chain state machine for each antenna path. The radio transmit flow is about getting analog hardware ready. Configure frequency and bandwidth, calibrate the DC offset, calibrate IQ balance and power amplifier, lock the local oscillator, then go TX active, driving the DAC and up converter. The receive chain handles energy detection, AGC, and carrier frequency offset locking. Then the LNA down conversion and ADC capture. Both sides can optionally drop to a sleep state, which ties directly into power saving. The real value of this diagram is in the arrows between the layers. The solid black arrows are normal progression. The dashed arrows are conditional or event-driven transitions like a retry loop, and the blue arrows are the cross-layer interfaces. You can see them explicitly. MAC hands the PHY a TX request. The PHY hands the radio IQ samples, and on receive, everything flows back up as RX indications. That bottom left box spells out exactly what crosses each boundary. Finally, the intent of this diagram is to abstract state machines for the concrete Wi-Fi 7 features. The enablers box on the lower right reminds you why these state machines look the way they do. Multi-link operations is literally why the PHY runs parallel per link. 320 MHz channels and 4K QAM with 16 streams drive the per-chain radio design. And target wake time and the advanced power state modes are why every layer has those optional sleep transitions. So to sum it up, the Mac decides, the PHY builds and recovers the signals, and the radio touches the air. And Wi-Fi 7's headline feature aren't bolted on, they're baked into the structure of the state machines themselves. Thank you.